Good to have you.
Nice to hear.
Spending the time with us. Good. Belgium,
Yes.
Ghent
Belgium.
University.
Ghent University, yes.
Yeah, I guess there's one university in Belgium where all this nutrition stuff is done. Cool. You're with DSM?
So it's very nice to be here today.
Yeah.
It's very nice and always nice to chat about mycotoxins. We do a lot of work already for quite some years now on mycotoxins. Always in very close contact with industry, so I always like that because then you have actually real-time feedback. Also with poultry producers, for example, it's very nice because then you know exactly what are their problems. Not only from a research perspective, but it's very nice to interact. And that's what I really like on the type of job that we do. It's from very fundamental research to, let's say, very applied.
Good. Yeah, then let's get right into it.
Yeah.
Let's start with the baseline around mycotoxins. What are they and how do they find their way into poultry feed?
So mycotoxins are secondary toxic metabolites. That means that they are produced by different fungal species, and these fungi grow on a majority of our crop species. So is it wheat, is it corn, for example, they will be there. So how do they find? Actually, they are very resistant. That means that whatever you do during processing of your feed, during storage, even might increase. So actually, it might be they are there. They even during processing levels will be the same. Some bad conditions of storage might even increase levels. So actually, it's something that we see that all our feed almost is contaminated. So that's very important. It's also very important to mention that not always the levels are very, very high. We see also most of our feed being contaminated at low, moderate levels. And I think what we're going to do this week here is really discuss these low, moderate levels. Because low, moderate levels will also have an effect on poultry, also on other animal species. And I think that's very important to talk about.
Yeah, definitely. So mycotoxins are a constant issue worldwide and they're quite persistent.
Yes.
What makes them that?
Well, what makes them so persistent actually are chemicals. And these chemicals can withstand very high temperatures. So that means that in the heating process during your feed production, they stay intact. So that means that it doesn't matter what you do, if you pellet your feed or whatsoever, they will stay there. You might have some metabolization to other types of molecules, but in general, they will stay there. And they will have then their effect on animals.
All right. So when they get into the animal, when they get into the gut, they damage all four components of the gut barrier. Walk us through these layers and give me some context around how that breakdown translates into feed conversion and disease outbreaks.
Well, if you look to the intestinal health, of course, very important is that always compare intestinal health. There are many factors having an influence on this. And one of them is, of course, feed. And it's important if you think about the intestinal barrier, it's first of all, it's all cells connected to each other. And these cells are connected to each other with, we call so tight junction proteins. And these tight junction proteins are regulating paracellular transport of many types of molecules, even of pathogens. And we, of course, want the epithelium to seal very well together. Because if this is not the case, always compare this as a kind of open door system. Because if the door is locked, you control who is entering the door. If your door is open, everyone who wants to enter can enter. That means that you can have leakage of plasma proteins from the blood towards the intestinal content, but also the complete other way around from the intestines to the systemic compartment. So that means that there, of course, you don't want to have this leakage, because leakage means also that the immune system needs to react. And a reaction of the immune system costs energy, costs feed. So that's a very important aspect where mycotoxins have an impact on. So mycotoxins will damage these tight junction proteins. Of course, then you also have your intestinal cells themselves, and we know that in the gastrointestinal tract, epithelial cells are regenerating very fast. And it has been shown not only in poultry, many different animal species, that mycotoxins will also have a negative effect on this proliferation. So also this regeneration is actually affected by them. Another layer of the intestinal tract which is forgotten a lot is the mucus layer. So on top of your intestinal cells, there you have a mucus layer. And this is kind of first barrier against chemical reactions, chemical friction. It's also important for if you think about microbiome, because certain types of bacteria also use this type of mucus. Also, or like think about the segmentous filamentous bacteria. These are good type of bacteria, also resident in this mucus layer. So there we have seen that the goblet cells which are producing this mucus layer are affected by mycotoxins. So they produce less of this mucus layer. And also in some research we have seen that the composition of the mucus layer is changed. And in that way that actually it's favorable for certain types of bacteria like Clostridium perfringens. So it's actually creating a mucus layer which can be used by this bacterium in order to grow, to proliferate. Then a third barrier is actually the microbes, the intestinal microbiota, as we call it. Well, there is of course a little bit more complex. If we look to the interaction between mycotoxins and bacteria, of course, from a historical point of view, we know that certain types of toxins produced by fungi have a positive effect, because our first antibiotics actually were a kind of mycotoxin. So not all of them are that bad, I would say, but most of them we see clear negative effect, of course, also on animal health. So there we see some direct interaction between the toxin and some bacteria. One of the examples is, for example, Salmonella. There we have seen that T2 toxin, for example, is intoxicating Salmonella. Of course, that looks nice, but of course that you see from the other hand what toxicity this T2 toxin has on the intestinal barrier, on all the different other aspects, is even worse. So that's not something that we want, but it's something important that we take that into account. If we then look to our other studies where we have looked to the interaction with the intestinal microbiota, there we actually see that you get some kind of shifts, for example, butyrate producing bacteria in some types of studies, they actually increase, sometimes decrease. And we think that this is kind of more indirect mode of action because they damage the intestinal epithelial cell layer. And by this damage, actually, you get some stimulus needed. And for example, butyrate, primary energy source of the intestinal cells, actually, so it stimulates regeneration after mycotoxin exposure. Of course, from the other end, as I said before, you have this paracellular transport, which is damaged. There it's also shown in a couple of studies that bacteria which are present in the gastrointestinal tract, like for example, Campylobacter, E. coli, Salmonella, might be easier to translocate from the gastrointestinal tract to the systemic compartment. And that's of course something we don't want, of course, because higher risk on food contaminants, but of course also higher risk for diseases, of infectious diseases. So there is a kind of dynamic interaction with the intestinal microbe on that end. And the last part of the intestinal barrier is of course your gut-associated lymphoid tissue. So the immune system over there. And there also it has been shown that different types of mycotoxins are interfering with immune cells. For example, they interfere with antigen presenting cells. So they make that they don't present the antigen very well to the immune system. And as a consequence, for example, your T cells will not react appropriately anymore.
All right. So beyond the gut microbiota, there's also an effect on the immune system level.
Yes, so that's one of the effects, that the antigen presenting cell is a typical example which is being affected. So it might also be T cells, B cells, and there it's really depending which mycotoxin. For example, aflatoxin, we know that's a very extreme one, and there we see very severe immunosuppression sometimes. It all depends, of course, on the levels. And that's one of the ways might be is T cell receptor suppression, that it's not reacting appropriately. Also the proliferation of these immune cells is sometimes affected. So yes, that's also an important aspect to take into account. And then if I translate this to the field, it brings me actually to vaccine response. Unfortunately, there is not a lot of research on effect of mycotoxin on vaccine response. If you look to the research done in poultry, Actually, the problem is that most of the research is performed with higher levels of mycotoxins. For example, deoxynivalenol at 10 milligrams per kilogram of feed, which is it's double of the current European Food Safety Guidelines values. So our question is a bit, what will happen if we go to more realistic lower levels of mycotoxins? Probably we still have these effects there. It will, of course, be more challenge to clearly measure them. But it has been shown for vaccine response, I just think like infectious bronchitis, Newcastle disease, so that the antigen response is not as good as it should be. Another aspect, for example, it's not in poultry, but for example, in pigs, there is also shown that for PRRS vaccination, for example, this is also shown that deoxynivalenol is decreasing the immune response for this. And that's just an example of humoral immunity. Cell-mediated immunity, then I think about, if you think about poultry, coccidiosis, for example. For coccidiosis, it's typically shown also that the reaction against coccidia is a cell-mediated immune response. There also mycotoxins will decrease this immune response. As a consequence, you have a little bit higher lesion scores and also problems with regeneration after coccidial challenge. So also there, you still have this interaction, but we definitely need to do more research, I think, about interaction with vaccine response, because I think that's important for the field.
Oh yeah, definitely. Many field problems, diseases that you already mentioned, but for instance, necrotic enteritis, they're multifactorial. How are mycotoxins connected here?
Well, I think necrotic enteritis is very interesting indeed, because we know that there are many predisposing factors. Think about, for example, just coccidiosis that we mentioned. The type of feed can be a predisposing factor. But indeed, what we have shown that due to the interaction with the intestinal barrier, these mycotoxins are creating a perfect environment for this type of bacteria to start proliferating. Clostridium perfringens needs amino acids to proliferate, and they will use them, which are there because of the leakage, but also because of poor digestion, absorption of nutrients. And then the bacteria will start proliferating and causing the disease necrotic enteritis.
So you have a vicious cycle to
Yeah, that's for necrotic enteritis, definitely a vicious circle, but it's not for all infectious diseases, because for other infectious diseases like Campylobacter, E. coli, it's more this translocation which is stimulated. You also have other diseases like coccidiosis, as I just mentioned. There's really an interaction with the immune response. Or Ascaridia galli, for example. Also there you see that there is a lower antibody response. So also here it's an interaction at the immune response level. So at many different levels we clearly see an interaction. And I think that's also important that we now look more to this, have more this approach for the mycotoxins, that we don't see them as a cause of clinical mycotoxicosis, but that we see them as a part of a puzzle in very complex diseases. Because nowadays, an infectious diseases mostly also doesn't occur alone. It's mostly at the farm you have a challenge of many different pathogens at the same time. And I think mycotoxins, in many times, they will all be there. We should take them into account, and they will probably play a role in this pathogenesis. So I see them as a part of the puzzle of complex diseases, complex disease challenges at poultry farms, but also for other animal species. This is a bit the same.
On the prevention level, when it comes to input, testing feeds for toxic loads, do we have the tools we need there?
Well, the problem actually, let's say that it's still the golden standard to test feed. And of course, there you have different type of approaches of testing feed. You have the very cheap, very fast techniques, and then you have the much more expensive techniques than if you think about like LCMS. And each of the techniques have their advantages and disadvantages. Of course, the big disadvantage of our expensive tools like LCMS is the cost. It costs really a lot to analyze every day all the different types of mycotoxins. But actually, we need this, because we need to know what are the challenges in a certain region for a certain feed mill. So I personally think this still has its added value of testing this on regular basis. Okay, and then based on that, you can use more the fast type of test They're much cheaper, but we know they're less sensitive. So less sensitive means you can only test a few types of mycotoxins, mostly very low levels. This might be sometimes difficult for them. And I think the major challenge for feed is that the levels might actually, in some spots they will be high, and in some spots they will be low. So the high we call the hot spots, and that's one of the big problems, of course, proper sampling. If you look to the problem of mycotoxins, I think over 70% of analytical error is really related to bad sampling. But it's still the golden standard, because then you know to what levels are my animals being exposed. So I think it's very important that the field try to set up good protocols to make sure on daily basis test mycotoxins, and you have also a strategy maybe to use a bit more expensive tools so that on a regular basis you can have a bit broader look. Also maybe important to mention a bit on this broader look is the emerging mycotoxins. Emerging mycotoxins are mycotoxins that we see a lot, but actually we don't know a lot about them. And then I typically think about eniatins, alternaria mycotoxins, bovirisins, for example. We see that almost all the feed samples and also food samples are contaminated with these mycotoxins. But we are still investigating how important they are. There are clear indications that a couple of them are important. But let's say there's still a lot of research needed for them. And these type of mycotoxins you will only be able to detect with the more advanced technologies like LC-MS. At the moment, there are no fast tests for them available. That's also important to mention, I think.
Okay, so on the level of presence in the gut, can microbiome and biomarker analysis help here?
Yeah, it's a question. I think we have to probably differentiate biomarker analysis, because if we talk about biomarker analysis for mycotoxins, there are a couple of options, let's say. And that's a biomarker of effect. And there we actually have the problem that only for fumonisins, you have this sphingosine ratio, which is one of the only biomarkers of effect of mycotoxins that we have at the moment. What does make so challenging? Because a lot of the mycotoxins are interfering with, for example, protein synthesis or just toxic, cytotoxic. Well, actually, it's difficult to make a specific biomarker for this, because we know that also other pathogens can do this. So that's really a challenging, let's say, part of the research. Another option is biomarkers of exposure. Then we will measure the mycotoxins or their metabolites themselves in different animal tissues. This can be blood, this can be bile or feces. But there we see that although it's interesting, we still see that it's difficult to make a correlation between these levels in blood, for example, and the level in the feed. So I think they definitely have their added value, but you have to do the correct interpretation of them. So also this is a very challenging field of research, and I think this will definitely grow in the future. And then coming back to microbiota analysis, well, it's not that mycotoxin exposure will result in a specific fingerprint of your microbiota. But microbiota analysis in general is definitely interesting, but then is of course the question, what does it learn us? If a certain type of bacteria will increase, because mostly microbiota analysis will result that there's a kind of equilibrium and that you will damage this equilibrium. And we start now to understand with the microbiota what type of microbiota do we consider as healthy and what type of microbiota do we say, well, this is maybe not optimal. So just analyzing microbiota in the field, I would not say that's where we have to go. I think there, of course, you have biomarkers for intestinal health that you can use. Of course, there we see that some type of biomarkers for intestinal health are still very in the research phase. And some of them are being used under experimental conditions. For example, overtransferrin, for example, is one of them which is quite often used. But sometimes we see that there is quite severe gut damage needed before you will see an effect on this. Also, of course, on the research conditions, it's easy. You have a control group, and you have a toxin group, for example, or a challenge group. But we see under field conditions that there are so many different aspects playing a role, which type of feed, which type of animal, and so on. So we see that it's much more complex. But there we see that might be one of the things you can also use, definitely, this type of molecules.
What can producers do to mitigate the challenge of mycotoxins when present in their farm, like binders, biotransformation, nutritional tactics?
Well, of course, mycotoxin mitigation starts already on the field, but mostly we as veterinarians don't have any effect on this. So therefore, mostly we go to feed additives. You include certain types of feed additives, and if you then have a broader look on what type of additive exists, so there you have some molecules which can bind a mycotoxin, then you have some type of products which can modify the mycotoxin. That is, of course, very important that there is clear proof that the modification is going towards a molecule which is less toxic. Not just that the parent molecule is disappearing, but it should be proven that what you are making is less toxic. And then what you sometimes also see is a kind of indirect mode of action, so meaning to support gut health, to support liver health. And important to mention with this is proof of efficacy, proof of safety. Because I get a lot of questions from the field. Okay, is this product working? This product working? My advice is always ask the company to provide you data that not only in vitro, but also in vivo data that products are working. Because it's not because clay, for example, bentonite clay, people think that bentonite clay is bentonite clay. No, we see a big variation in the binding capacity of bentonite clay, for example, for aflatoxins. Because aflatoxins, we know that's typical mycotoxin that you can bind, but we see that some of them, although it's all bentonite, have a very low capacity to bind them, and some of them are binding them 90% or more. So there, it's very important, proof of efficacy and proof of safety. Because safety, there is a safety aspect, and that's mainly when you're overdosing, and then you can bind nutrients. We also have shown that you can bind even antibiotics. But in our studies, actually, it was only when you exceed the advised inclusion rate times 10 or even more. And then if you think about modifiers, they are mostly very specific for a certain mycotoxin. So it's one mycotoxin has a specific toxic group, for example, and with an enzyme, or for example, a type of microbe, where you will focus on this toxic group. But since the mycotoxins are so diverse, they all have a different mode of action. The disadvantage of this technology is that you have to target mycotoxin by mycotoxin. And so therefore you see mostly that the field products or the products on the market is mostly a combination of these different types of mode of action.
Right. So how does tackling mycotoxins fit into the larger antimicrobial resistance and sustainability agenda?
Well, actually, if you look to an interaction of mycotoxins and antimicrobial resistance, actually there are not many papers about this topic. Very recently, there is one study indeed showing an interaction also with antimicrobial resistance. So that's actually, they showed with some E. coli isolates in the lab, of course, that there was induction of antimicrobial resistance. So from that end, but I think we definitely need to explore this research field more in the future. But how I see this interaction more on antimicrobial usage side. As we said before, mycotoxins and even low, moderate concentrations are making the animals more susceptible for infectious diseases. So which in the end will lead automatically to higher antimicrobial use. So it's a part of complex diseases. And complex diseases mostly result in antimicrobial use. So there's still a lot to do on that part, but I would say these low, moderate levels of mycotoxins, even if sometimes difficult to clearly show in an experiment an effect on animal performance, it's still there. So we definitely need to investigate this more. There is one recent publication that indeed calculated this effect on global warming and emissions, for example. And there, of course, it's not that it will induce more emissions, but the interaction is again indirect, because you will have an effect on performance, you have an effect on susceptibility for infectious diseases, and so on. So that means that in the result, with the same amount of feed, with the same number of animals, you will produce less. So in the end, to have the same goals, you need to produce more, you have to use more feed, you have to have more animals. So yes, there is an indirect link, of course, also with that part. So it's, yeah, they actually play a role in many different aspects, let's say, which are challenging for the industry. Yeah.
Now, for poultry producers out there, for the farm managers out there, like, what is the message you want to get to them about what they can do about mycotoxins today, and how are they able to manage loads in their feeds and in their animals?
What I really see as an important aspect is that we should not forget about clinical mycotoxicosis, because we definitely see, depending on where in the world we are, we sometimes see clinical mycotoxicosis. But I think almost all our feed is contaminated with low, moderate levels of mycotoxins. So we know that our animals are continuously being exposed. And these are at the lower levels of toxins. And it has been clearly shown, and also European Food Safety Authority has suggested to significantly lower the most of their guidelines values, showing that these low levels have an effect. And where is the effect? Mainly, it's really intestinal health and immune system. So I think it's important, even if they don't see clinical mycotoxicosis, that they are aware of the challenge of mycotoxins, and that they take this into account, and that it might play a role in making animals more susceptible for infectious diseases. So that actually they consider it as a part of the puzzle for good performance, good animal health. I think that's very important for our poultry producers, or in general, our livestock producers.
Excellent. Good one, Gunther. Thank you very much.